Hi, everybody. Welcome to our lovely session here. I'm very excited to talk to you all about probably every buzzword in the industry we could possibly jam into one session. Hybrid, machine learning, DevOps, Kubernetes, like just TensorFlow, take your pick. Like we tried to fit it all in because
Bingo.
We're inclusionists here.
Yeah.
Like we like to include everything.
Everybody.
Everything, every solution, all of it all at once. So we'll kick things off. We like to just introduce ourselves so you kind of can know who we are and what we're doing here. So my name's Rob Schmit. I am a customer engineering manager for Google Cloud based out of Chicago. I primarily work with our large retail customers to help them adopt the cloud and transform their businesses. And over to my left here is...
I'm Ryan McGuire. I'm a CTO of Augmented Intelligence for a Fortune 500 digital transformation consulting company out of Chicago. We're a partner with Google, so happy to be here. Let Rob take the stage.
All right. So let's start with a little bit of definition of kind of what we're doing. So what is the edge? Like it's a lot of things. It can kind of be anything you want to define it as. But for our purposes, we're really talking about areas of constrained compute where you have potentially a limited amount of resources in which you can execute your model. So, in data centers, oftentimes people are going to be running just straight TensorFlow in IoT devices that sort of change things. With mobile, there's lots of different techniques and things we can use depending on where we're going to go. But the fact of the matter is that machine learning models are going to be running everywhere on all of these surfaces very soon. So we need to start thinking about how we start to transform these devices and bring the services to them. And we need to do that for a number of reasons, right? Obviously with Google Cloud, we have lots of really awesome vision APIs that are very easy to adopt and give you a fair amount of things, but that comes with a cost. So for latency reasons, you might not be, you're going to have a round trip time trying to get anything up to those APIs or back. Bandwidth is also an issue when you have not a lot of, if you're on a mobile network or you are in an area where you don't have a good connectivity back to the cloud. Privacy reasons, there's reasons to do things on devices and not ship things up to the cloud, particularly with things like, for example, like very, very sensitive healthcare data or sensor data or things that are very private. Connectivity, as we sort of alluded to, is always going to be an issue, especially in IoT scenarios, and obviously execution cost. A lot of times it can be quite expensive to hurl a lot of data and a lot of compute up in the cloud to get this kind of stuff. But the cloud still has a role, and we need to think about how we leverage the cloud for what it's good for, and how we leverage the devices for what they are really good for. So to that end, obviously in the cloud you have the computing power. Obviously we've got GPUs and TPUs available that you can bolt on and use to accelerate your machine learning processes and get things done faster. And that leads right into the velocity. So you're able to move and iterate quickly by using things like Cloud ML Engine and other tools like that. The elasticity, you scale up when you train, and when you're done, you turn it all off. So you're not having to have dead weight resources just sitting out there. Data storage is really another area where the cloud makes a lot of sense because you have to centralize and aggregate a lot of this data in order to train your models. And obviously, training cost is really good if we use things like preemptible VMs and other things like and on the elasticity. We're then able to minimize a lot of that stuff. So there's really three considerations that we need to think about when we're starting to think about running a machine learning model at the edge. One is the model and binary size. Obviously, a lot of these models are going to be running in memory, so if you don't have a lot of memory, that's something we need to control for and make sure we get that as small as possible so that it's able to run in those scenarios. Obviously, that also has an impact to the speed at which it's able to run. If you're using a lot of the memory already, you're not able to push transactions through it as fast. And it also can impact application performance. And as we look at that, slow performance in an application is a killer. People will not tolerate that these days. And you have to start thinking about your device itself and threading. So by default, TensorFlow sets that to the default number of cores on the device, but we need to understand that hardware profile so we can decide, do we need to utilize more cores? Do we need to utilize more threads in order to move forward? So that's all great. Like, we all understand kind of the problem space. But how do we actually go there? And there's really 4 phases that we need to think about, and there's a lot of constraints and considerations that we need to take into account at each one of these phases in order to get our model out. So first, we're going to talk about building the model. Obviously, we're primarily talking about TensorFlow here, and the reason we're talking about TensorFlow is because it's a very flexible execution environment and training environment for machine learning. So we're able to actually utilize it to go straight from the cloud to the edge with very little change to the actual machinery that we're running on. But when we can start to consider the problem and what we're doing, we need to understand where we're going to be putting this model at the beginning. Choices you make at this stage of the game have a very severe downstream impact if you're not considering them. So we want to understand where we're going to be running this model. Is it going to be running on a Raspberry Pi in a closet? Is it going to be running directly on a piece of machinery? What kind of hardware environment? What are the latency requirements of this particular model that we're going to be trying to run? And understand that, like, as we make those choices, we're going to be constrained in several different ways. So whether it's the RAM or the compute performance, whether it's the size of the model or the choice of the model that we're going to use or build, we need to understand at that point what we're going to be doing so that we can choose the right model and build the right model. So components at this point, like, there's a lot of different things that we use. Obviously, TensorFlow I talked about, but having Jupyter and IPython notebooks so your team of engineers and data scientists can iterate quickly and share the data and get everything moving quickly is important. Kubeflow, if you're in on Kubernetes, Kubeflow is another great pattern that people are starting to adopt because it kind of homogenizes a lot of that, like training infrastructure and IPython notebooks and sharing and all that stuff. Obviously, the thing, like the big glaring hole that everybody needs to think about is training data and testing data. If you don't have enough data, there are ways around that. But obviously, we need to have good quality data so that we're able to actually build this model and get good performance out of it. But in some cases where you don't have good data, or maybe it's not particularly good, you can start with a pre-trained model from TF Hub, pull that down, and then you can do a little bit of transfer learning on it to accelerate yourself and not maybe be constrained by as much data as you may need. So when we look at the actual training of the model, first, we have to make sure we've got enough data, as I just said. Another constraint that we need to think about is how fast do we actually need to do this training? How often are we changing the model? How often are we looking at actually improving the model? Because that has an impact too. If you are in an IoT use case in manufacturing and you tell your plant manager that you're going to have to take a whole machine down for 3 hours so you can update the sensor model, they're not going to be happy with you. That's money just flowing out the door. Another thing to think about at this point is what we call quantization. Quantization is something that you package into the actual training execution in TensorFlow. And what quantization does is it simply takes the graph. So TensorFlow executes in floating point by default. But on an edge device or on a very constrained area where you don't have a lot of GPUs, you don't have a lot of floating point operations, that can be really hard to run. It's like really hard for mobile phones to run all that floating point stuff at the moment. So what quantization does is it takes all of it and flips it into 8-bit integer calculation. Now there's a consequence to that. So you're going to get the performance and you're going to get a lot of increase in boosts, but your model is going to be less accurate now. So when you quantize the model, you also have to make sure that you're understanding what that accuracy loss is going to be and what you actually need to be successful. Obviously, in a lot of various industries, there's going to be specialized hardware. As we're starting to see, we announced edge TPUs and things like that. So we're starting to see some changes to how we're actually building these things. And that's an important thing to understand here, because you have to know what you're going to be running on so that you can actually make sure that the execution environment is good. And obviously, one of the big risks to training is always data bias. Oftentimes we bias the data unintentionally. We walk in with the best of intentions and wind up doing it ourselves because we're humans and we're biased. So understanding that you might not have all the data, or you might be excluding certain kinds of data that have an impact to your model, is important as well. So in this, as we look at kind of the architectural components that we would use here, obviously Kubeflow can be a training and an execution engine. You can use that. CloudML engine for like the fully serverless style of training and execution is another good component too. And obviously using TPUs and GPUs at this point are really good, because it's gonna start to shrink that time down that you're gonna need to actually build this model out and get it trained and tested. So moving on to the preparing the model phase. So at this stage, really what we're trying to do is understand that we got to understand what the performance characteristics of the model are going to be. A lot of ways things that we can do are built into the TensorFlow libraries themselves, but we want to make sure that we understand exactly what we're going to be doing this model on and how it's going to execute in the environment that we're going to be running it in. So a couple of tools that we can use are the TensorFlow Profiler. This is a great built-in tool that can give you actual performance metrics based on the graph that comes out of the training session. And then the other thing that we start to look at this point is the TF Lite benchmark library. So if you're in a mobile or in a like a sort of an IoT situation, TensorFlow Lite is probably the destination you're going to wind up at. It's built in. What it does is it restricts a number of heavyweight hardcore CPU operations from the model, and it comes with a custom protocol buffer that lets you execute it's specifically designed to be executed in mobile environments. And so what you do is after you quantize your model, you're able to run this converter called COCO, and that's what turns it into the actual TensorFlow Lite graph that you can then take and execute. A couple other things to consider at this point are model encryption. Obviously, a lot of these models are running in memory, and it's not baked. Encryption is not baked into TensorFlow or TensorFlow Lite, but it is available to build. There's a little tutorial up on the TensorFlow website if you are concerned about people scraping the memory and taking your model and doing something else with it. So that's something that you also want to consider at this point as well. At this point, now we got to actually get the model running, and there's a number of different ways we could actually approach this situation. Obviously, we could run in containers. We could run natively on Android or iOS, package it right into our app. Do we have edge TPUs? Are we using Android IoT? We could have Kubeflow deployed to an edge location, like for example, if you have a fleet of different service centers with small data centers inside of them, like 3 or 4 NUCs from Intel. You could deploy Kubeflow there, and then you have a nice, really end-to-end service at that point. But you kind of need to take into account everything that you've got rolling in your data centers and where you're going to be, and make sure and think about how often at this point in time you're going to be training that model, right? So if you package everything into an app and you retrain your model, well, guess what? Now you got to push a new app out to the App Store. Like, people got to go and download it and update it. So there's often times you need to think about, like, okay, like, how am I going to do this so that I'm giving my users the best experience, given the fact that I'm probably going to be training the model more frequently than I'm going to be updating the application, because that's going to be a key thing that happens here. The thing about machine learning is it doesn't really stop. It has to keep going. So with that, I would like to bring Ryan back up on stage to talk about the journey that his team has gone through to trying to execute a very similar vision as the one we just talked about.
Thanks, Rob. So we're going to talk a little bit about an example today about COCO. For those of you who know COCO was a gorilla who learned sign language. Actually, COCO was born here in San Francisco, just down the road at the zoo. And over a period of time, she learned sign language, was able to communicate. So we're going to use that as a model today to demonstrate what Rob talked about some of those flows. At Solstice, our mission is to prove what humanity is capable of, and what a better way to take machine learning, computer vision, neural networks, and an experience to kind of help those in need to prove what humanity is capable of. So we're going to walk through the slide a little bit and talk about the steps that Rob talked about. First step being, building your model, using the cloud and the power of the cloud to do that. Here we had a series of images that we used to train the model to make sure that we selected the right model. As Rob had talked about with the deployment model of the edge, we want to give consideration to the things that we might not have thought through. So what operations could go through a TensorLite conversion, and how would we do that? Should we use an object recognition that's already trained, or should we train ourselves? Should we use SSD? Should we use VGG? Those types of things. So in this phase, we started to work out a lot of those types of things using the power of the cloud with Google Compute Engine to do those types of things. Really important in this space is to have your training set and your test set aligned up. So I'll show a demo in a little bit about using a sparsely trained set. We'll call her COCO Jr. She only knows 3 letters. And then we'll show kind of a demo of COCO Sr. being trained on a full set of data, different hand gestures, different colors, left and right, and those types of things to have a more rich and robust model. Once you have that model and you've got it built, you want to train it. You want to set some validation points. So, am I comfortable at 50% accuracy? Do I need a 90% accuracy? How much coverage do I want? So we'll talk a little bit about how we did that there. And then this whole quantize. It's a cool word, right? The edge, quantize. This is where you now get to take the power of the cloud and compact it, right? A whole world in a teeny itty bitty bitty space. Right? So putting it out to the edge, so getting ready to do that. So we use quantization to do that conversion down to TensorFlow Lite, and then we use traditional means of CI/CD pipelines. So we're constantly training the model in the cloud with new imagery and data that we have, and we have a CI/CD pipeline that we'll demonstrate in the application, where we're able to make the switch between COCO Jr. and COCO Sr. In near real time, which is really important to the user experience. Does that make sense? Yeah? Who wants to see COCO? Before we do, I want to talk a little bit about the differences here. So you can see the top track, we have COCO Jr., who's only trained on A and B with a minimum set of observations. That model is available in a version in our continuous integration environment where we can pull that down from our storage bucket. On the bottom, we've taken more of a robust approach using the power of AutoML engine, imagery and data to really train COCO Sr. to know the soup to nuts alphabet and interfacing with the application. So with that said, I'm going to bring up COCO Jr. if you could switch over the displays. So here we have an Android app displayed here on screen. Image recognition, cameras on. You can see the image process over here, which will do motion detection once we put up a hand signal. But as demos go, let's see if she's working. She worked. She knows A. Yay! However, if we go to H, which is this signal, no letter detected. But to prove out that she knows B, we can go ahead and put up B signal. So she knows B, but she's only 61% certain that it's a B. So now what we're going to do is we're going to pull down through the CI/CD pipeline that we have available with COCO Sr. trained. So we've got these buttons that basically toggle versions of the model back and forth inside of the application so that we get the latest and greatest. So we're going to go ahead and update here to COCO Sr. And as you can see, COCO Sr. is now taken over, but nothing's really changed from the experience. So we can go ahead. Okay, so she knows A, but let's see if she knows H. O. So you can see that the power of having data in a different training set brings you to the next level of what you're capable of doing. I could show you right-hand signals. We could have a small children's hand, a woman's hand, and a man's hand. All these are different signals into your environment when you're thinking about the model that you're creating. So your test inputs, your data set are very important. But let's envision for a second that we took this to the next level. And we didn't have that training set. You could have the power of a continuous learning cycle with COCO that could go into training mode, and now it's capturing images, and you're allowing your user population to feed back into that loop, creating your training set. You're not going to run that locally at the edge. You want that information to go back up into the cloud, and we're going to talk about it a bit in a second. I'm going to call Rob back up here. If we could switch back screen. Oh, I'm going to click this. So, Rob, is this how it works in the real world today with COCO?
Yeah, but it's truly that's only half the story. As we look about this, like at this point, it's like, congratulations, we've deployed a model. Like, yay. Everybody's excited, but there's so much more we actually have to do at this point. And as Ryan alluded to, we've got to get feedback from the users. We've got to aggregate the data. We've got to organize the data. We've got to update the model. We got to keep going through this cycle onward and onward and onward. So, a couple of things that I really liked about the approach that Solstice took in this model was they sort of decoupled the app execution from the actual model graph, which is pretty slick. So were able to deploy that out to a CDN basically, and have it going back and forth right there without having to update the app itself. So putting that logic into the application was pretty smooth. And I think that's a good pattern that you're going to start to see people adopt going forward.
Yeah. Well, and I think it's a really important thing. You talked about something that all of us that are intimately familiar with, right? The software engineering practices. That cycle is never done. You never finish an application. You're always constantly grooming it. So at Solstice, we've adopted an approach called continuous learning, which is a mix of agile principles, reinforced learning, supervised learning, which we take it through a cycle, very much like we talked about today and in that prior slide, going from selecting your model and experimenting, training your model, the initial flow of that, evaluating what are your criteria for getting it out the door, and going through each one of these steps, but it's evergreen, it's never stopping. We're using modern software engineering principles, CI/CD process, maybe some A/B testing in here to put our model out into production and get our feedback. So you can envision an NLP chatbot that is, making a recommendation for a particular purchase order and asking for validation from the end user. Was that right? And then that flowing back into the process so that we can elevate the capability of our machine learning models in a commercialization to go from just reasoning for a human to actually helping make decisions. Yep. So one of the things that we'd like to do is just kind of walk through between Google and Solstice, put together this model of like what an ideal state architecture is and how that might fit into a model to give you guys the tools as you walk away from this conference, this meeting, and you think about how you're going to take forward what you've learned here today and apply it to your business. So we'll start with the experiment and train section. Here, using GCP, we've lined up the ability to use BigQuery, Bigtable, and other cloud storage as kind of that foundation data layer. And we'll talk about it later as how that true feedback data flows into it. But you can see you've got your dev cluster and your prod models living side by side, creating that trained model that's constantly evaluating new sets of data and new points of data inside of that. Anything to add there, Rob?
Yeah, I think it's an important piece that you need to have that I think people don't think about as they're going through this is curating your data and making sure that you have a consistent environment for your teams to actually build and experiment with these models on, and making sure that you're doing that in a safe way, making sure that everybody has access to what they need, making sure you're respecting user privacy and all the other concerns that we have in software development, and then you give them the opportunity to just go right from that spot to cloud machine learning and do the actual training execution. So you're basically unconstraining them now from resource usage. And that's, I think, the ideal state. So it's going to let people move quickly and actually start to execute these patterns rapidly.
Yeah, no, I think that's great. And this kind of blueprint gives well, where do I start and when do I end? And how do I start it again, right? And so it's a really good model to it. So stepping out of that, it's into the evaluation, the deploy stage. You can take this, for what it is at this level, or you can even go further detail. So put in whatever your continuous integration CI/CD tool of your choice in this spot. Again, using that Kubeflow to deploy to the edge, containerizing, packaging, doing the TF-Lite, using Spinnaker to get it to the edge device. But inside of this, you could get more sophisticated. Say you had a confusion matrix that you wanted, 90% along your confusion matrix. You want your ROC curve to be these types of things. In your continuous integration environment, like you do today with your web applications, you could set a threshold for coverage, right? these models are set to have these types of facilities to be able to measure the validation of it. Your deployment here doesn't necessarily have to overlay the production model that's there. You could put that behind an A/B testing platform. Say 80% of your routes are going, to the old model, while 20% are going to the new. So you can really measure the value of those types of things. This is the type of space where we're taking the history of what we've done as software engineers and product folks and bringing that into the model and integrating that into your application.
Yeah, 100%.
What do you think about that?
Yeah, no, it's absolutely something I think needs to happen. Right, I think people need to start taking a lot of the things that's painful about machine learning, like the performance testing, the regression testing, figuring out what the limits are and all that stuff, and automate it away. Like we've done that with regular app deployment.
Yeah.
Like we need to do it in machine learning now, because that's the thing that's going to start to let us move faster. It's also going to let us start to put controls and rigor around the testing. Right, rather than relying on somebody manually rigging up a test, we're going to be able to make it a piece of the pipeline, and it's just going to happen. Another thing to talk about that this model sort of highlights is this concept of localized training. And one of the things this is really where Kubeflow shines. This is the thing that Kubeflow is awesome at. So one of the things that's super important is when we look at the cloud, right? You're going to be training against all of your aggregate data out up there. But when we look at certain scenarios like weather forecasting. It's
like
potentially
maybe like rain down in Africa.
Potentially.
Potentially.
I'll bless the model and then hopefully we can get it going.
Yeah.
But it's important, right? There's going to be regional differentiation. There's going to be different scenarios. There's going to be different conditions at the edge, and you might want to like tune a model at the edge, right? In certain scenarios to fit this case. So a classic, obviously I spend my time in retail. A very classic use case of this is demand forecasting in stores. It's very easy to forecast demand on an e-commerce site because it's all coming through one channel, right? When I look at a store in California versus a store in Florida versus a store in Maine versus a store in Texas, all going to have different demand and supply costs. So if we start to optimize the supply chain and make those predictions, we probably want to start training on all of our aggregate order data across all of our stores, figure that out. Then we deploy it locally to the store and train against the transaction log that's coming in from everything that everyone's buying. And that localizes it, because we might get bad predictions if we're looking at the whole store, because all of our transactions aren't necessarily representative of what's going on in each individual store.
Yeah, it's that continuous learning piece, and taking the localization factor to it, right? Like a majority of the models, like we used an object neural network for animals that have 4 classes, and that's where we started COCO from, and we transitioned that to learn the alphabet. Same type of thing, right? In store, you have different parameters, like you can tweak down at that level, but the base is always the same.
Yep. You're training down there, and then you're just executing another set of training down at the edge.
The last piece, I think, is one of the most important factors as we think about the maturity of models in the commercialization space. So how do you get a model to be better? How do you take it to the next level? How do you elevate it from an MVP to a version 2.0? We like to talk about models in AI going from an infancy state to a reasoning state, and then ultimately moving to a decisioning state, so that we can augment the human element, so that we can help the human get better, and ultimately make those decisions on their behalf with a high degree of certainty. Different businesses have different risk thresholds and tolerances, but in our experience, we don't see those models kind of move forward without taking this feedback loop in or additional data to adjust in the marketplace. So this is a really important component as you think about your architecture and you think about your deployment of models, is how are you capturing the customer sentiment? How are you ensuring that what you intend to happen is happening? Compliance and regulation, learning about how did you arrive at a particular conclusion and what would you do next time when you're there. So it's a really important event, and making that loop back into the cloud where you're actually feeding that event data back into your training set.
Yeah, 100%. And even then, this also feeds the automation more, right? Once we build the model and we have that object and that artifact, we might make tweaks to it. We might change little things for performance reasons. Lots of little things like that. But really, the thing we're going to be constantly doing is training it and training it again and training it again and training it again. So if you build this pipeline like this, you're able to automate all of that stuff away. So now your high value, hard to find, hard to hire data scientists and machine learning experts are able to keep going and working on new stuff rather than having to continue to maintain a model over and over and over again by hand, right? So this is I mean, it's very much reflective of the changes we've seen in the industry to this point, especially as we look at app development and kind of the way that space has evolved over the past 5 or 6 years, and bringing that same sort of rigor and decision to machine learning.
Yeah, no, that's great. Well, thanks for allowing us to have the opportunity to come up here and talk to you. Hopefully, you guys have walked away with a little bit more insight and knowledge as you kind of wind down your time at Next, and really appreciate it. And if you have any questions,
we're open for questions. We've got about 15 or so minutes left, it looks like, and we're happy to take any questions you might have.